Well, hello everybody on the internet. It's great that you've joined us. I'm here. We're going to do some boat testing, and with my wife, who's a head teacher. She's going to keep us in control. And my good friend Martin Ridge, who is a chief engineer. Are you still a chief engineer? Is it like being Mr. President, where you're always chief?
Well, I still have a license, but I just don't go to sea anymore.
You don't go to sea anymore. You're a typical engineer. And how about you, darling?
I don't go to sea at all.
Okay, well, splendid. So what we're going to do is test two motors. One is a Mothership Marine motor, and the other one is a Vetus motor, 10 kilowatts. Action stations, everybody. It's exciting.
7, 8, 9, 1.
That's one now.
Okay, that's 40 kg.
Talk to me.
1.9, 1.2.
2.
78. 105. 155. 190. 260.
Going full power now.
11. Peaked at 320 on full power.
I'm quite impressed by that. I wonder if we caught it on the drone. Hope so.
So what was the result?
320 kilograms, which translate to nearly 3,000 Newton meters. So take two. This is Slapdash Lily with a Vetus motor, and we're going to take her out now and run all the tests. And just to be fair, we're running in power mode of the Vetus.
Thousand, 1.
That's 1.
Okay, that's 38.
1.8, 1.9, 2.
2.
53. 70. 5. Okay, that's 100. Okay, going to 7.
6.8, 7. 7.
Okay, that's 135.
135. On maximum throttle now.
10.2, 10.25.
Hang on, I've got to perhaps repress power again. Hang on. Press power again. Get extra power.
9.
What's that?
9.5. 9.5.
9.5. That's 9.5.
160.
that's an interesting conclusion. So I'm easing back now on the throttle, and then we'll take all of these numbers apart in the office when we get back to base. So, all looking good for the moment. Thank you, sweet pea. Back on dry land, in the workshop, great experiment out on the water today. The experiment went much as I expected it to, and here's why I think that was so. So this is the propeller that's specified by Vetus. It's a 13-inch propeller with a 9-inch pitch, and this is one of the ones that we at Mothership recommend. It is a 20-inch propeller, considerably bigger, considerably heavier. I'm going to put that down, but look at the size of the blade surface area here. If you think of that in terms of traction in the water or tyres on the road, a big car tyre versus a small car tyre, it means you're going to get a lot more grip. Think of it that way. Now, why do Vetus recommend the smaller propeller? And the reason for that is that their motors need to turn fast, which does mean a little bit more noise. And the reason for that turning fast is because they have an air fan on the front of them, which they need to cool the motors down. Ours have a full water jacket, think of full metal jacket, it is a metal jacket, around the whole of the motor. So when it does eventually need cooling, we just turn on the water cooler, and most of the time we don't have the pump running, and it's perfectly quiet. So why, in my opinion, are large propellers better than the small propellers? Well, there's two reasons. One, quietness. The other one, efficiency. Quietness because large propellers revolve a lot slower and there's less noise associated with that. And the other reason is because there's so much more grip with large propellers, they are more efficient. And if you're in an electric boat with a limited amount of power, then you want to make sure that you use it as efficiently as possible. So large propellers are better than small propellers, and motors that drive large propellers are better than small propellers. So back on the water, everybody, and this story does have a happy ending because Slapdash Lily now has a very powerful and very quiet Mothership Marine motor. That's me. This is my smoke face.